Example number 2. Find the coordinate of the center, the major vertices, the minor vertices, and the foci of the following ellipse. Thus, find the length of the latus rectum and the eccentricity. So now, the equation is given as x minus 3 all squared divided by 16 plus y plus 2 all squared divided by 25 plus 1. To solve, before you solve any problem, I would advise that you should first know your ellipse. Are we having an ellipse with a vertical orientation or an ellipse with a horizontal orientation? What's the answer? Well, to know that, let's look at the axis that has the highest value under it. This has 16 and this has 5. So this has 25. Since y has the highest value, that means we are having an ellipse with a vertical orientation. It means, the value of C, the value of A will be along the y path. Am I communicating? Perfect. So now to get the coordinate of the center, C would be, like I said, take the value along the x path that is attached to x, value attached to y, alternate their signs, put it inside, and that's all. So that will be 3, minus 2. And now we can do, if you actually want to be simple, okay, you can just set x minus 3 to be 0 and y plus 2 to be 0. It means x will be equal to 3 and y will be equal to minus 2. So these are the center of the circle. Because I said circle, ellipse. So now, this has gone. We have the center already. Now we need the major vertices. Capital letter MV. That will be, remember, it's not at center. It's not at center. So it will not be 0, plus or minus A also. It should be H, the value of A, or let it be K, first, K plus or minus A. Now here, this is how it's expected to be expressed. So we need the value of A. Remember, A will be the largest. So we take A squared to be equal to 25, and this implies that A will be equal to 5. And B squared will also be 16, and this also implies that B is equal to 4. So basically, since I have the value of K to be minus 2 and H to be 3, remember, that will be H, K, 2, respectively. And that will be equal to the value of H is 3, the value of K is minus 2. Something minus 2 plus or minus 4. So I need to express this and simplify. So MV, I need it in capital letter. The major vertices would be, the first one will be 3, minus 2 plus 4, that's plus 2, and 3, minus 2 minus 4, that's minus 6. So this is the coordinate of the major vertices. Now, for the minor vertices, the work is MV. Remember, that will be in relation to the value of B. Now, B will be along the x-axis. So we have H plus or minus B, K. Am I communicating? Perfect. So that will be equal to H is what? H is 3. So we have 3 plus or minus. The value of B is what? B is 4. With them, excuse me, I made a mistake here. Instead of 4, it's supposed to be 5. This is supposed to be 2 plus or minus 5. That's the value of A. I instead put the value of P. Okay, bad. And this will not be 2. And this will not be minus 6. So minus 2 plus 5 is 3. That should be 3. And this should be minus 2 minus 5 is minus 7. Excellent. So that will be 3 plus or minus the value of B is 4. So now we can split that and have lowercase mv, the minor vertices, to be 3 plus or minus again. I haven't put the value of k, which is 2. So that will be minus 2. Okay, plus or minus 4. Then comma, the value of k is what? Minus 2. Okay, hope you're not lost yet. So this is h plus or minus b. So b is 4. And we have it right here. Then the minus 2 is this one, the value of k. Am I communicating? Perfect. So that would be 3 plus 4. That should be 7. So d should be 7. When we are trying to expand everything, that will be 7, 2. And 3 minus 4, that will be minus 1, minus 2. So this is the coordinate of the minor vertices as well. So that is that. Onto the foci. Please, if you're following, that's how you can easily solve problems on ellipses. For the foci, since it's a vertical orientation ellipse, the foci will have its value along the y-axis. So, and also, since it's not centered at the origin, the value along the x-axis will not be 0. Instead, it will be h, the value of k plus or minus c. Perfect. So we need the value of c actually. Okay. Now, since c squared is equal to a squared minus b squared, c squared would be equal to a squared is 25, b squared is 16. C squared will be, the difference of these two is 9. And taking the root of both sides, the root of 9 is 3. Okay, perfect. So it means the foci, its coordinate would be h is 3. This is the value of h. That's 3. So we have 3, the value of k is minus 2. So we have minus 2 plus or minus 3. Are we together? Perfect. Now for those who might be like, the root is plus or minus 3, you are still doing the same thing. You understand? When you need them, you put it. Okay? It's expected to be put and it will be there. It's actually in the formulas and the way we put all these things. So using positive like this is still perfect enough. You feel me? So we are just trying to consider positive values. Because some of you might be wondering, yeah, I might have people who might be like, why am I using plus 3 when root of 9 is plus or minus 3? Well, the case is still perfect. Understand? Just considering positive values. So now, let's simplify. Let's expand this. So that will be 3, plus 2 minus 2 plus 3. That's plus 1. 3, 1. And 3, minus 2 minus 3 minus 5. So that's the coordinate of the foci. That's the coordinate of the foci. Perfect. And that's the solution to the center, major vertices, minor vertices, foci. Now we need the Latus rectum. So LR would be equal to 2b squared over a. That's 2 times 16 divided by 5. That will be 32 over 5. In how many different ways can 5 go in? 32. 6 remains at 2. That will be 6 whole number 2 over 5. So that's the Latus rectum. Eccentricity E is equal to C over A. C is 3 and A is 5. And that is the eccentricity. And that's also the solution to example number 2. And as simple as that. On to example number 3.